All right, in physics, remember there were some scientific steps to make an search in science. These are called scientific methods. And there were some steps in these methods, starting from asking questions, making a hypothesis, testing hypothesis, and then conclusion or something like this. So now there's a part of this scientific method. It was the testing hypothesis. So how to test an hypothesis? How can we test an hypothesis? For example, tell me, let's say that we are going to, somebody's saying that length of this table is 1.5 meters. So now by looking at the table, they can give some information about this table. But how do we know it's exactly 1.5 meters? So that's why to test this hypothesis, we need to measure that table by using a measuring instrument. So we are going to use some measurement instruments, and we are going to measure the length of this table, and we are going to test our hypothesis. So how do we test hypothesis? By making some measurements. So by making measurements, so we test a hypothesis. So now, what things do we measure? So one of them is the length. So we measure the length of the table. So the first thing we measure is length. Is that all? No other quantities we measure in life? Of course we have some other quantities we measure. For example, you want to know how much sugar you got from the market, so you should measure the mass of an object. What else do we measure? For example, general students are measuring the time. So how many minutes do you have until the end of the lesson? So we measure the time. What else? So especially in Süleymaniye, the temperature is really hot. I mean, it's hot in air. So we measure what temperature? We measure temperature. These are four very known physical quantities we measure in our life. But besides, there are some other quantities maybe you are not familiar. Which are they? One of them is the amount of matter. The other one is the electric current. And the last one is luminous intensity. As you see, the first four quantities very familiar. We measure the length, you measure the length, mass, time, temperature, every day. But fifth, sixth, and seventh are a little not very well-known quantities we measure. So amount of matter is a little about the chemistry. Electric current is about the physics, but you are going to study in the 11th grade. Luminous intensity is about intensity of light. I mean, how powerful a light source is, how bright a light source is. Luminous intensity defines that. So these seven, this number is important. These seven physical quantities, they are called physical quantities: length, mass, time, temperature, amount of matter, electric current, luminous intensity. These seven quantities are called in physics as fundamental physical quantities. So these are fundamental physical quantities. Why is it called fundamental? You will understand when we explain the other quantities. Now, but when we make measurements, right after the measurements, we are not going to length of this object is 10 meter, or mass MACSS is this, time TIME is this. So instead, we are going to use some symbols. For length, we are going to use L. for symbol. For mass, we are going to use M for symbol. And for time, small t. For temperature, capital T. For amount of matter in chemistry, generally we're going to use N. For electric current, it's physical quantity. In physics, we are going to use so many times capital I. Luminous intensity, not so much used, but it's one of the fundamental quantity, which is the IV. So these are the symbol. Symbol means represent length. L represents length. Mass represents M represents mass. T represents time. Capital T represents temperature. N represents amount of matter. I represents electric current, and IV represents luminous intensity. These are the symbol of these 7 physical quantities. But we measure in physics the quantities not this way. For example, we never say length of this table is 10. So in physics, generally we have, in measurement, we have a number. Right after the number, we put a unit. For example, 10 meter. Meter represents the length. For example, 5 kilogram. 5 is the number. Kilogram represents the mass. So, or 10 degrees Celsius. 10 is the unit, but degrees Celsius, 10 is the number. Degrees Celsius represents the unit. So, in physics, every measurement must contain a number and a corresponding unit. For example, what is the unit of length we measure? It's the meter. What is the unit of mass? It is kilogram. What is unit of time? It is second. What is unit of temperature? It is Kelvin. What is unit of amount of matter? It is the mole. What is unit of electric current? It's ampere. Unit of luminous intensity? It is candela. It is similar. Candela. So of course these are the units of those physical quantities we express the measurement. 10 meters, 5 kilograms, 30 seconds, 10 Kelvin, 1 mole, 12 ampere, 100 candela. These are the expression expressing the results of physical measurements. But these units also have some symbols. For example, meter is M, kilogram is kg, second is S, Kelvin is K, mole is mole, ampere is capital A, candela is CD. Okay, so every unit again has a symbol. Like every physical quantity has a symbol, every unit also has a symbol. So you shouldn't confuse them, because you cannot confuse them, because when you say mass of an object is 10 kilogram, you write this way. M is equal to 10 kilograms. So you can understand this is representing the mass, this represents 2 units. For example, length is equal to 10 meters. So this represents the length, represents the meters. So you can understand. Now, if you look at this table, you will see that meter, kilogram, second, Kelvin, mole, ampere, candela. These units are these are the units of the fundamental quantities, but these units standard in all over the world. So everybody, so when you are making a calculations, you use the meter. When you make they make a calculation about the mass, they use the kilogram. When they make a calculation about time, they use second. Or temperature, they use the Kelvin. For amount of matter, mole. In chemistry, you are familiar with this. In electric current, ampere. So these units are called SI unit system. SI unit, or standard international. So which means international unit system. So every scientist or every one of you should use these units while you are making a calculation in physics problem. But all the units in physics are like this, in fact not like this. For example, you can also measure very shorter length by centimeter. You can measure the kilogram by gram, or sometimes with ton. You can measure the time by not only seconds, sometimes by minutes, sometimes by hour, you can measure it. So temperature, for example, we never use Kelvin in our life, we use degree Celsius. Americans use Fahrenheit, degree Fahrenheit. Amount of matter, we don't know about the chemistry, how do they use, but for electric current, ampere is used, yes, it's ampere. For luminosity, candela is used, but the rest, sometimes we can use other units besides the SI unit system. Okay, so now we know basically how many fundamental units in physics, in length, mass, time, temperature, amount of matter, electric current, luminous intensity. These are the 7 fundamental units in physics, and their symbols and their SI units and symbol of their SI units. But we know that sometimes other units can be given in the problem. You need to convert this unit to this SI unit system before making any calculation in problems. So how to make this conversion, you are going to learn in this section in the following titles. But these 7 fundamental quantities, besides these quantities, physics also have other quantities. Like what? Like area. Area is a physical quantity. Like volume. Like density. Like velocity. Like acceleration. Like force, like energy. So these are also physical quantities, but these quantities are different than that. These 7 are basic, fundamental, which means fundamental quantities. These are called derived quantities. Derived quantities. What does it mean, derived? Which means these quantities are obtained from fundamental quantities. By different combination of these fundamental quantities, we get those quantities. For that reason, every derived quantity has dimension of this fundamental quantities. For example, area. Area is calculated by multiplying the length by another length. So sometimes this length is known as the width, but it's length and length. So when you multiply 2 lengths, so dimension of area becomes square of length. For example, volume is multiplication of length times width times height. In fact, it is when we measure the length, width also is a kind of measured in length. Also, height is length in dimension. So when we multiply these three, we will get the dimension of volume as length cube. So density, for example, density in physics is defined by mass divided by volume. Mass is a fundamental quantity, so its dimension is as it is, mass. But volume divided by volume is a dimension of length cube. So dimension of density becomes mass divided by length cube. What about the velocity? Velocity can be calculated by, you are going to learn about them later. Now this is now explaining about how to write their dimensions. In fact, you are going to learn them in the 11th, for example, for density, you are going to learn about the 11th grade. For density, you are going to learn the section, one of the sections, section 3, I think, in this book. We are going to define them, but now I am explaining how to write the dimension of a physical quantity. For example, velocity is, if you look at the 11th grade book, you will see that it is the distance divided by time. Distance has a dimension of fundamental quantity length. So distance divided by time. So time is a fundamental quantity. So then dimension of velocity becomes length divided by time. Acceleration, it is defined as the velocity divided by time. So velocity has a fundamental quantity length divided by time. Dimension is length divided by time. If we divide it once again by time, we will get the dimension of acceleration as length divided by time squared. So these are the ways how to write the dimension of a physical
quantity, but these physical quantities are generally derived quantities. Now, by looking at these dimensions, we can also calculate or get what the unit of area is. Area. So, unit of length is meter. Meter squared is the unit of area. Volume. Dimension is length cube. So, what is the unit of length? Meter. Meter cube is the volume, unit of volume. Density. So, it is mass divided by length cube. So, what is the unit of mass in SI system? Kilogram. What is the unit of length? Meter. So, kilogram per cubic meter is the SI unit of density. Velocity. Length divided by time. What is unit of length? Meter. Time, second. Meter per second is the unit of velocity. What is acceleration? Acceleration is length divided by time squared. What is unit of length? Meter. What about the time? Second. Second squared. So, meter per second squared is the unit of acceleration, and so on. You can get the unit of any derived quantity from the dimension. But force, energy, and others, some quantities, how to get their dimensions, you are going to learn in the 11th grade. Force, energy are some other quantities. You are going to get their dimensions, and you are going to get their equations in the 11th grade.